Get rolling? Okay, then let's get rolling. Yeah, hi and welcome to the session on, well, Java EE, Jakarta EE, MicroProfile, or maybe all of them. A session that is supposed to have a little bit more clarification with all that chaos or with all these Java enterprise standards that we have now. And I want to show you, well, what to choose for a modern enterprise Java project, for a modern real-world applications, what makes sense, which standards or technology to choose from. Sorry? Oh, okay. My name is Sebastian, born and raised in Munich, and I work for this company called IBM, and I do a lot of things with enterprise Java. I was in a JCP, or still am. I'm a Jakarta EE committer and heavily involved in that technology. And well, I want to show you a few things on just enterprise Java. So what we have, if we have a look at Jakarta EE, I mean, if you think of Java EE is dead. It's called Jakarta EE now. And what I would call the good parts, at least according to me, then because if we look into Java EE, that all of that is now part of Jakarta EE, there are a lot of things in there, right? The platform is huge, a lot of technologies that we might not even need anymore, right? If you think of SOAP or other things like that. But what I want to focus on is basically the good parts of Jakarta. That is CDI, right? That's at its core, right? For injection and all these type of things. We have JAX-RS for RESTful web services, JSON-P, JSON-B for JSON binding, JPA, JTA for transactional databases, right? EJB, but only in the version 3, right? Only the modern stuff. Then it contains things that are really needed. Bean validation, interceptors, and things like that. But if we have a look into that, I'll have some comparison later on. It might not be enough for modern projects, especially if we use cloud native technology, if we use like containerized environments, orchestration, things like that. And that is where, well, we can see what is missing from it. So if we have a look at resiliency, for example, right, like some fault tolerance aspects, things like circuit breakers and approaches like that, we can always implement that using plain Jakarta EE, but there's not much part of the standard yet. Same is true for observability. If we think like monitoring, things like distributed tracing, none of that is in Jakarta EE yet. Injectable configuration is another thing, and that is where MicroProfile comes into play. So if we have a look at the website, that is the website jakarta.ee. I like the .ee top-level domain. That is now the new world of Java EE. And MicroProfile basically emerged by, well, that situation where we didn't see much innovation in Java EE back then in the past. So a few vendors came together to, well, craft a new, smaller subset of standards that is just able to innovate a little bit more. So you can have a look at the website here, microprofile.io. And now again, for MicroProfile, if we have a look at how that landscape looks a little bit, where a few people are confused. So on the left, we see Java EE, what was there in the past with everything that's included, like JAX-RS, CDI, things like JPA or EJBs, which will be Jakarta EE in the future, or actually it is right now, Jakarta EE 8. And also we have MicroProfile. And the thing is, what I want to focus on, it's based on the same technology, right? It's based on enterprise Java, it's based on CDI, JAX-RS, but it also comes with a few more projects that lead to more innovation, like MicroProfile config and a few other ones. And just like I showed you before, now again, the good parts, according to me, of MicroProfile that we need for modern applications is what you saw from a few of them from Jakarta, like CDI, JAX-RS, and JSON, but also a few projects that are only contain a MicroProfile, like MicroProfile config, fault tolerance, metrics, health checks, and things like that. Now, as I told you, I want to look at that from a real-world perspective, and the question, okay, what should we choose for a real-world project, right? And if you look at modern cloud-native microservices, both technologies on their own might not be quite enough to solve the things that you want to implement, right? If you think of, for example, applications that need like persistence and things like that. So if we look into a few development options that we have, for example, what I showed you before, we could choose to take only Java EE, right, like Java EE 8 or now Jakarta EE, which is, well, a proven technology, and it includes a lot of things. But as we saw before, there might be some missing parts, right, in terms of observability, for example, or resiliency, fault tolerance, these type of things that are not included yet, right, where that alone might not be quite enough on modern cloud-native based applications. But also, if we, for example, take MicroProfile on its own, like in a version 3.0, for example, then, well, what we get, it's quite nice that it only includes modern and slim, lightweight APIs, only the modern stuff like CDI, JAX-RS, but it's also hardly enough for real production applications, for real-world applications, where we typically need things like, databases, JPA, JTA for transactions, where we need some more complex concurrency applications, where we would need the concurrency API and things like that. We have some EJB timers and just some things where, plain MicroProfile isn't quite enough. But now the point is, what I want to show you, we actually can have both. And the reason for that is it's not competing technology, but it's based on the same standards. It's based on the same application specifications. So what you saw with CDI, what you saw with JAX-RS. And if we do that, then we get the proven technologies and the APIs that are known to a lot of developers, like CDI, like JAX-RS. But also we kind of use these MicroProfile projects to fill the gaps that we have, right? So for example, we could have Jakarta plus MicroProfile config, or plus config and fault tolerance and metrics and open tracing and things like that, right? So I think that makes a lot of sense for real-world applications. And now enough talking, I'm not a big fan of slides. I want to show you some code. So I want to show you this in some live code fashion, where we have a Jakarta project, Jakarta EE 8, that uses also Eclipse MicroProfile. And this is perfectly valid from a technology point of view because it's based on the same standards. And I will show you how to do that, especially with some modern runtimes. Hope the font size is big enough on that projector. So what we have is a project that I built for a thin WAV file packaging approach. It also has some reasons. And I only include 2 dependencies. In the past, there was only 1. In the past, for modern Java EE projects, we had the Java EE 8 dependency only. Now we have the Jakarta 8 dependency, also very important as provided scope, because thin deployment artifact. And now we have a second one for MicroProfile. Eclipse MicroProfile, that is the POM dependency that includes everything. If we like, for example, only config for reason or only specific projects, we could also inject them independently. But I think it makes sense to just get all of it from the API perspective, and then we can use whatever we like. All right, so the rest of the project is empty. What I want to start with is just plain Jakarta, which most developers would be familiar with. So I have a JAX-RS configuration class here that is just empty. And then of course we will code some hello world example. So let's start with some endpoint, some JAX-RS resource, something like greetings. So hello/greetings will end up at some resources, and very basic example. For example, we say hello and hi and things like that. And that just should emit a very basic, boring hello world resource, right? So we can do that, which now only uses Java EE APIs. So we can do either this right away, or what we actually would do, we would of course inject some component like a business component, for example, provided by CDI. Let's call this hello, right? And so I have a class that basically gives me these hello world resources, and then I say hello, please say hello, and hello, say hi. So that's super exciting, I know. But that is the basic hello world example that now only uses Jakarta for now, which then we want to enhance with Eclipse MicroProfile. So that is basically the idea, to see, okay, we can have both, and then we see where that real benefit is, especially of using both of these technologies, right? So they're really compatible, and not only that they're compatible, but it actually makes a lot of sense. Let's say there's an application scope, CDI bean or something like that, whichever scope would make sense here. And well, then we can deploy and run this, right? So that is also a thing that I want to show you quickly, how we would run that in an opinionated way, in a somewhat best practice, especially for container-based deployments. So what I would do here, I have the command line here, that is a Maven project with a thin wall approach. So of course I would build that using Maven, right? Like Maven clean package or Maven clean install or something like that. And the reason why I do this with that approach is it's quick. It builds really fast. Why? Thin deployment approach, the WAR file that it builds, wherever it is, WAR file that it builds here is tiny. If we have a look at that, the hello war is 4 kilobytes, right? Because it only includes the classes that we write. It doesn't include any of the framework or implementation or something like that. It literally just includes our stuff, which makes a lot of sense if we know how containers work under the hood. So what I will do, I will deploy this using Docker containers. So I have a Docker file to create a Docker image with, well, any technology of your choice. I use OpenLiberty as an application server. So that is an open source application server that is, I believe, one of the most modern and innovative ones that supports actually Jakarta and MicroProfile. This will be important in a second. And well, in this case, I use a Docker base image that just comes with, of course, Java. In this case, I use Java 12 and an application server that is compatible with Java EE/Jakarta EE and MicroProfile. And then I just have to, well, drop my application. And that's pretty much it. I can, if I like, enhance the configuration here, but that's about it. So this is a very simple Docker file. And good news is it makes use of the copy on write file system approach of the caching that Docker uses under the hood. So if I call this, I don't know, hello, then it builds this very, very quickly, right? Because, well, you saw it, the WAR file is tiny, right? And if you know how Docker does the building and the caching for the build and also the transmission, like push and pull, this is really, really fast because you actually can transmit the whole image by just pushing a few kilobytes if you already pushed, the base image. So you don't have to push the whole, I don't know, hundreds of megabytes with the whole image, including the whole runtime, because your application is tiny. So that's the benefit of that. All right, anyway, let's run our image with Docker run, and the port 9080 is the default port of Liberty. And then let's see how that works. And then I can access my Hello World application finally, right? So I go to localhost 9080, application name was hello, so that ends up in the context. Root greetings, hello. Then I end up with hello or hi. Exciting, I know. All right, but now let's add, I can stop this again, which by the way is a nice example of seeing that modern enterprise Java runtime doesn't have to be, slow, heavyweight. If you think of old, I don't know, WebLogic or WebSphere, where you have to wait half an hour for the startup. Luckily, that has nothing to do with that. It starts up really quickly. But also what I want to show you, now I want to include a few more technologies from MicroProfile, but I also want to show you a different approach how to run that stuff in order to get a little bit of faster development experience, right? Because what you just saw, I did the Maven builds, I did the Docker builds, and the run, but it took like, I don't know, 30 seconds in total, which is okay-ish. But if I want to, write some code and if I want to try it out, that turnaround is just too slow, right? I mean, in 30 seconds you get bored, you take some coffee, right? You check social media, and then your mind is somewhere, but you're out of that flow experience, right? So actually what you want to do, you want to have a quicker turnaround. And there's some tools out there, specifically one that I really like for Liberty. I have to say I'm typically not a big fan of Maven plugins, so I try to keep that as simple as possible. That's also the reason why it runs that quickly, my Maven build. But that is one exception that I make here. The plugin for the Liberty Maven plugin, why? It comes with one killer feature that is called, if I can type my alias correctly, Liberty Dev, which is a development mode for, well, Liberty that runs my OpenLiberty in a special mode while developing, where it actually detects your changes that you make in a project and then has, well, a hot swap mechanism where it just very quickly restarts your application and can hot swap classes under the hood, and then you get your changes much, much faster, right? So once that is the case and it starts up quickly, then you can just make some changes in your code and see the changes immediately being reflected. So once that is up and running, I can go for the Hello World resource, and then I can actually, let's go that into code, I can actually make some code changes and have them being reflected quickly. So here we see hello and hi again. Exciting, I know. But now if I say hello exclamation mark, then what it does, it will very quickly update my application in like, less than a second, and then the response is there, right? Hello exclamation mark, hello question mark, and you will get your changes immediately being reflected, even on an end-to-end fashion. So I can not only rerun my unit test on a code level, but I can literally change the code and see the change being reflected on the actual application server. So that's quite a nice thing, and it really improves, the development experience, and especially, the effectiveness, your productivity as a developer. So you don't get distracted by social media. You can say, you have no time to check social media. Literally change the code and it's right there, right? But now back to MicroProfile, what I want to show you are some more features here. For example, let's include, something like MicroProfile config, or let's start with something simple like health check, right? There is MicroProfile health that I already include because I include, well, the whole umbrella of the MicroProfile dependency, so I can add MicroProfile health for here. Let's do a very basic health check. Let's say that is defined as a readiness health check. It matches what, well, Kubernetes defines as liveness and readiness probes, and then it looks like follows that we implement some interface here that says, well, you can programmatically health check for, well, whatever you like, and then depending on, what your application includes, you can check the database and any other connection, you return a response on whether your application is, healthy or not. So let's call this the health check resource for hello, and assuming once the application is being deployed, then it's always, healthy, so it's always up, it's always green. We could, again, change many more things if we like to. And then the nice thing is, even if we include some, like features here, let's have a look at the server XML, I can actually, well, change that on the fly. So that is the nice story about this Liberty development mode. So that is Liberty specific. That is a list of features that I actually activate, that I include. So this uses OSGI under the hood to basically just pick and choose the features that you need. You don't even have to do that. You can say, well, just use all of Jakarta and use all of MicroProfile. That works as well. That is just a little bit of an optimization because, well, then the startup is faster because it literally only loads what you want to have. And if I now activate that for health check, if you know about MicroProfile health, then you know that is the default resource / health. Well, then it's included now. You saw I didn't restart the server. It's literally, there right away. If I include another hello world or hello EclipseCon resource, then as well, it will just reload the whole thing, and there it is. And that is true for all of the stuff you have in your application, right? Like classes, you can add some features, or configuration. Let's do some configuration here. Assuming we want to have, say, we add an additional config resource, an additional JAX REST resource, while the whole thing is running, just because we can. Let's say we have some /config. And I told you about MicroProfile config before, right? That enables you to do injectable configuration, which is quite nice because what we can do, let's say, to have an add-get method config, some other method that just, for the sake of the example, emits some configuration. Where does that come from? Well, what we can do with CDI, we can just add inject stuff, right? And CDI is pretty powerful. We can define our own, like qualifiers and add inject whatever we produce in a producer somewhere else. And we have done that a lot for configuration to basically inject our own custom configuration, right? But with MicroProfile config, the nice story is that already comes out of the box. If you take add config property as a qualifier and then say name with whatever configuration key you want to have, for example, let's call this greeting, then let's inject some greeting here. We can inject that there, and same story, we'll redeploy hello/config, right? And say, hey. Okay, where does the hey come from? Well, this will actually go and take a few of the what is called default config sources that come with MicroProfile config. So for example, environment variables, very helpful for containerized environments, or config properties, property files, or system properties. And there is one default configuration, resources, meter-inf MicroProfile config.properties. So you don't have to configure stuff, just take the convention and property file that you can configure here, and then you can just write stuff. Nice story is actually that Liberty plugin knows about that location and will detect the change in that file location also, and just hot swap it as well, so you can just redeploy very quickly and you don't have to restart that server. It just literally is whatever you do while coding will just auto update that for you as well. So that's very helpful, especially if you do that type of stuff. All right, let's go back to that list. What else we can talk about? MicroProfile metrics, for example. MicroProfile metrics is a nice thing that comes out of the box as well. So it's one of these things where you say, well, everything you saw you could do with plain Jakarta as well, right? Like health, just include a JAX-RS resource and things like that. It's just less effort to do for yourself. The same is true for metrics. So MicroProfile metrics actually will include some default metrics under /metrics. That looks a little bit weird. That is the Prometheus metrics format. You might have heard of that, which is a line-based plain text format, which includes things like what is the available processors here in my on my system right now, and what is the used memory and other stuff like that. So of course that is not meant to be consumed by humans, but the Prometheus format, that's what it is. It's the de facto standard for monitoring in a cloud-native world. So you can have a Prometheus instance scraping these things, and which is a time series database, and then you can consume it using fancy Grafana dashboards and things like that. Anyway, nice story is all of these technical metrics come out of the box. There are some metrics that MicroProfile requires the implementation to have. Or if we say, hey, by the way, we want to have our business-related metrics, that actually might be much more interesting, right? Like how many orders have been ordered in the last hour, or how many cars have been produced, or how many hellos have been called, right? Things like that, which we can do using the API. So it comes with an API. So for example, we could inject some counters or some other metrics that we then can programmatically increase, for example. Or what we can do is like having annotation-based declarative approach, like @counted, where we annotate a method where you, literally count the method invocations. So for example, let's say hello's total. That's like a format that we would use for this invocation of that method, of the hello method, which, again, will be picked up, and then all of that will be just redeployed. So let's say hello, greetings, hello, 1, 2, 3. And then we go back to the metrics resource, and we see a new metric counter being included with the total number of hellos, equals to 3. And then you would go in your infrastructure, point your Prometheus resource to that metrics page, and then you get all of that, business-related metrics. Again, easy on the technology side, but now very convenient from a developer's perspective, because you literally just, have to have a few lines of code, either by annotation-based development or by injecting that programmatically, and it's just now much easier to use, especially in that combination, if you use MicroProfile metrics in that case. All right. Fault tolerance, another fun thing. Assume we want to add some, fault tolerance aspects For example, we have a circuit breaker concept, you might have heard of that, or timeouts, retries. For example, circuit breakers. So assuming something goes wrong in the application code where you have, I don't know, like a client connection, things like that, where at some point you want to include or you have to include some circuit breaker component that just, fails or fails early without, burning down the house that circuit breakers do, where there's also a helpful component, a helpful declarative way of doing that with add circuit breaker. So that is just one example of MicroProfile fault tolerance that I can show you in this time. It's also quite big specification that includes a few things. But if we add that circuit breaker annotation on this method, then it's guarded by a circuit breaker. So what that does mean, we have a few default configuration thingies here. So for example, what it does, it has a look at a window of the last 20 or let's say 10 invocations, requests, and then depending on how, what the failure ratio is, 0.3 failures, then at some point it will open that circuit. So basically, what does a failure mean? Well, out of the box, it's an exception, right? So if you get more than so and so many exceptions, then the circuit will be open, and then you will not invoke that method anymore for the next so and so many requests for per default 5 seconds, or let's say 3,000 milliseconds, and then it will be half closed again, and then depending on the status will be closed or not. So that is the default behavior of that. Again, you could do the very same thing by using interceptors, right? Interceptor API in Java EE, you can have something like if I could type interceptors, right? And then point to an interceptor where you can do the same thing, right? You can around invoke for a method and then check, oh, do I have an exception, and increase a counter or not, and just code that yourself. You probably did that, right? But it's just more code than annotating it like that. So let's do this, and then of course, well, it works, right? There's no exception; it will not fail. So let's change that. Just because I can, for fun, let's make this fail. Say if new random next double is less than 0.3, then throw an exception, right? Bam. Just because. Otherwise we don't see, whether we configured the circuit breaker correctly. So now we updated that, and now we see either hello or bang exception. HTTP, do we have some, hold a second. It's either okay, or what do we see? We probably see some exception here. Internal server error. And what we can do for the status code. So then we see, sometimes we see an error, and let's ask for a few more requests. Depending on how many invocations we have, then at some point, if we get too many, then the circuit will be open. No, it won't. It won't trip. Let's redeploy this so it's more proper that it will happen, and then we that's the thing with not only live demos, but live demos that rely on random, right? That's the best thing to do. Let's redeploy this again. Yep. No? There we go. And then depending on how many arrows we have, at some point we would trip the circuit breaker or not. And it's less than, I have to increase that number, right? Oh, thanks. Somebody's paying attention, I like that. And then it would just, trip the circuit, and then at some point we only get the server errors. Let me exclude this. So we actually see that we get different resources, exception, invoke state, exception, and at some point we get, where's my command line? we get that's what I want, the legal state exception. I cannot read the exception now. What you would get then if this circuit breaker, let me show it to you like this. What you would get if it's open, then you would get a circuit breaker open exception from MicroProfile. So that is the different exception that you get then, and once the circuit is open, and otherwise, it would just work. What else you can do? You can define a fallback. So that is then a fallback method that will be called accordingly. You can have retries, you can have timeouts, and all kinds of things. Again, it's just the same concept that you have. Again, declarative programming. The nice story is, if we are familiar with Jakarta APIs, that is pretty much how Jakarta or Java EE APIs would feel like as well, right? So as enterprise developers, we're pretty much familiar with that concept. And again, that is just one way to do that. So somewhat as key takeaways, what I showed you, we could customize the runtime. That is basically this server XML feature thing. I would say that somewhat as that's an optimization issue, right? So if we further want to optimize what our runtime includes or not, that makes sense, we can do that. But from a POM XML perspective, I actually advise folks to just have it simple, just include both dependencies where you get the full platform, and whether or not you use all of the APIs, it's just easier to do. Very important, do that as a provided scope, so it doesn't end up in the deployment artifact. Everything else I have here is just for testing purposes. Speaking of testing, if you want to include that, actually, what is also a nice app of this plugin, what it can do, it can run your tests. Well, for that I actually have to have some tests. So let's write some tests first. Why? Well, same story, development experience, right? You want to have a fast, where is it? Why does it not, oh, wait a second. You want to have a fast turnaround time. So for example, running your test quickly for, well, getting that turnaround fast in order to, for example, only run, let's say, plain JUnit, right? So I'm writing while I'm talking, that's always a bad idea, a quick JUnit test that just says, well, assert that this hello is equal to hello, which I think is wrong because it should be uppercase and things like that. So I'm just unit testing this class here, and that point is, well, once my IDE started up, this runs quickly. So I can test this for the hello and the hi, right? And that is just a super simple unit test. I will write an integration test in a second as well, so that should be uppercase. And once I rerun this, then it will either in the API, or now that is the part of this Liberty plugin, just run my test and say, okay, green, test run, right? Very simple. If I want to rerun them, you can hit enter. So if you prefer to run it in the command line here, you can do that. You could also do the Maven invocation if you like, or of course in your IDE, just rerun that test, and then you say now you have 2 unit tests that are green. Okay, that's easy. Another thing, in Maven, if you name something IT for integration test, then you have an integration test, right? So what you can do here, let's have a private final. I included some what I call hello system that basically gives you capability to say, oh, please get the greeting for my hello response, right? So say, please assert that this hello greeting is equal to hello, right? And of course the same for hi, and of course the same for my config, right? So I have more resources here. We'll get system get config equal to hey, and now I want to verify that all of that is the case, right? Now this is much more interesting, because what it will do, it will actually, the hello system, go to that resource as an HTTP client and basically test that system from the outside. So since I still have that Liberty Dev plugin running locally, I can actually rerun this. So we have one failing test, which, well, because I renamed the properties, I need to change back, right? Now what you will see, and that is the workflow I want to have. I change some code or I change some configuration, it will hard reload whatever I'm doing here. I could go back to the config, I see my change here, but more importantly, I can run my unit test and my integration test in that plugin. It also runs the integration test, and then they will be green, with that quick development turnaround, which is just, very, very nice as a developer. So as some key takeaways, we want to use a combination and choose some technology where, we use these known APIs, which I think is a huge benefit of Java Enterprise because we used to most of these APIs. And then what I would use MicroProfile of for now as, think of it as an extension where it fills all of these gaps, right? With config, with observability, resiliency. And what I always like to do is to use a development model that fits your need on the application side, right? Like this thin deployment artifact that works well with your containerized environments. We can go and take that container image and deploy it to Kubernetes or to OpenShift, whatever you want to do. And I would optimize the deployment artifacts before I optimize the runtime, right? Before you go and say, oh, how many megabytes does my image have in total? I really care about the size of the deployment artifact, the last image layer that I always keep redeploying, that this is tiny in terms of, kilobyte. So it really runs and deploys quickly. And by doing that, I think it's, a combination that works really well, Jakarta with MicroProfile. And yeah, I hope this was helpful, and thank you very much for your attention.